The lock manager subsystem maintains mutual exclusion guarantees across concurrent database operations. All resource access requests route through the lock acquisition interface, which serializes requests according to transaction identity and resource identifier. Lock modes include shared, exclusive, and intent variants. The system maintains lock request queues per resource, processed in first in first out order. Acquisition failures block the requesting thread until the requested lock becomes available or a timeout threshold is exceeded. Lock grants are tracked in an in-memory hash table keyed by transaction identifier and resource pair. Each entry stores the assigned lock mode, acquisition timestamp, and a reference to the requesting thread context. The lock grant table supports concurrent reads through a reader-writer locking mechanism at the table level. Writes occur only during lock acquisition and release operations. Scans of the table occur during deadlock detection cycles, performed at configurable intervals or triggered by timeout events. The deadlock detection algorithm operates on a wait for graph constructed from active lock waits. Each transaction occupies a vertex. A directed edge exists from transaction A to transaction B if A is blocked waiting for a lock held by B. The detection routine executes depth-first traversal from each vertex, searching for cycles. Cycles indicate circular wait conditions. Detection runs every 30 seconds by default, configurable via the parameter deadlock check interval MS. When a cycle is detected in the wait for graph, the system identifies all transactions participating in the cycle. The victim selection mechanism examines the transaction state and execution history. Selection criteria include transaction age, number of locks held, and estimated rollback cost. The system applies a weighted scoring function combining these factors. The transaction with the lowest score becomes the deadlock victim. Victim selection is deterministic given a fixed transaction population. Upon victim selection, the system initiates forced transaction rollback. The rollback operation reads the transaction on due log in reverse order, restoring database state to the transaction's start point. During rollback execution, all locks held by the victim transaction are released. Lock release operations notify waiting transactions, allowing them to proceed. The victim transaction receives a deadlock error code. The application layer must handle this error and optionally retry the transaction. Lock release operations reduce the count of locks held by a transaction. When the count reaches 0, the transaction enters a released state and can proceed with commit or final cleanup. Partial lock release is supported, allowing transactions to release individual locks while maintaining others. Lock release is idempotent. Releasing a lock not currently held returns without error. Release operations wake one waiting transaction from the locks queue, selected in FIFO order. Intent locks provide hierarchy-aware conflict detection for multi-level resource hierarchies. Intent shared locks indicate a transaction will acquire shared locks on child resources. Intent exclusive locks indicate exclusive access to children. Compatibility rules follow standard hierarchical locking protocols. Intent locks conflict with explicit locks at the same level. Child locks must be compatible with parent intent locks. Intent lock acquisition precedes explicit child lock acquisition. Lock escalation occurs when a transaction accumulates locks beyond a configurable threshold. The system monitors per transaction lock count. When the count exceeds lock escalation threshold, defaulting to 500 locks, the system attempts to acquire a coarser-grained lock covering the same resources. Escalation reduces lock table overhead and decreases deadlock probability. Escalation is attempted transparently. If coarser-grained lock acquisition fails, the original fine-grained locks remain active. Timeout-based deadlock detection provides an alternative detection method. When a lock acquisition request remains blocked for longer than lock wait timeout MS, defaulting to 5 seconds, the waiting transaction is forcibly awakened. The transaction receives a lock timeout error. Unlike cycle-based detection, timeout detection does not examine the overall graph structure. Timeout detection applies uniformly to all lock waits regardless of cause. Both detection mechanisms operate concurrently and independently. The lock compatibility matrix defines which lock modes may coexist on a single resource. Shared locks are compatible with other shared locks, but incompatible with exclusive locks. Exclusive locks are incompatible with all other lock modes. Intent locks follow a distinct compatibility pattern. The compatibility matrix is stored as a two-dimensional array indexed by lock mode enumeration values. Matrix lookup is constant time. The matrix is immutable after system initialization and consulted for every lock acquisition decision. Lock statistics are maintained at transaction and global scope. Per transaction statistics include acquisition count, release count, and average hold duration. Global statistics include total lock table size, number of queued waiters, and deadlock event count. Statistics are accumulated in thread local variables and aggregated periodically. Collection occurs every 60 seconds by default. Statistics are exposed through monitoring interfaces for external observability. Statistical data is not persisted across system restarts. Deadlock prevention strategies reduce deadlock probability through resource ordering. The system assigns a unique ordering identifier to each lockable resource. Transactions are required to acquire locks in increasing order by resource identifier. Ordered acquisition eliminates the circular wait condition necessary for deadlock formation. Prevention requires application layer cooperation. The prevention mechanism is optional and disabled by default. When enabled via prevent deadlock via ordering, strict ordering enforcement is applied. Violations result in acquisition failure. Lock wait diagnostics provide visibility into current blocking relationships. The diagnostic interface exports the current wait for graph in edge list format. Each edge includes source transaction, destination transaction, resource identifier, and wait duration. The export operation acquires a snapshot view at a single instant. Diagnostics support programmatic query by transaction identifier to retrieve all locks held and all locks being waited for. Diagnostic operations do not acquire locks and execute in constant or linear time relative to active transaction count. Lock implementation uses spin locks at the internal level to protect lock table data structures. Then lock contention is minimized through fine-grained locking by resource. Each resource maintains a separate spin lock protecting its lock queue. Hash table buckets protect their respective contents. Spin lock duration is bounded. Lock acquisition and release operations complete in constant time assuming lock availability. Contention statistics count spin lock acquisition attempts and successful acquisitions. Contention monitoring detects performance bottlenecks. Configuration parameters controlling lock behavior are set at system startup and remain fixed during execution. Parameters include deadlock check interval ms, lock wait timeout ms, lock escalation threshold, and prevent deadlock via ordering. All parameters have documented default values. Parameter validation occurs during initialization. Invalid parameter values result in startup failure with diagnostic messages. Parameters are read from the system configuration file. Dynamic parameter modification is not supported. Parameter changes require system restart. Error handling in lock operations follows standard protocol. Lock acquisition failures return specific error codes indicating cause, incompatibility, deadlock, or timeout. Rolled back transactions return code 13, deadlock victim. Timeout failures return code 14, lock timeout. Acquisition errors do not modify transaction state. The calling transaction remains active and may retry or abort as appropriate. Lock release errors are rare and indicate data structure corruption. Such errors trigger diagnostic dumps and system shutdown.